Welcome. In this video, I will be kind of showing how we can take the idea of tangent line and create a function that relates all possible slope of those tangent lines of a function. So basically, we're finding a function that can tell us the slope of a function at any point x. So to start, we are going to define some notation ideas. So again, the slope of the tangent line is what we call a derivative. So what we're finding is the function that gives us a derivative. So let's say we had a function f of x. The derivative of that, or the function that gives us a derivative, but we just refer to it as a derivative, is what we call f prime of x. So this little slash on top of the f is a prime. Let me write that better, actually. Make it clear what I'm actually trying to write here. So it's f prime. So f prime gives us the slope for every point of f. And another notation is this d over dx. And this basically means find the derivative of whatever function is here. So we often see d dx of some function, or they won't always have it as f of x. They'll just have the function itself there. But this just means find the derivative. Think of it as the small change in the function divided by the small change in x. That gives us the slope of a tangent line, right? So that just equals f prime of x. And sometimes instead of even using f of x, they will use y as the dependent variable of a function. So y and f of x are the same thing. So we end up writing that as just dy over dx. And that is the same thing as f prime of x. Both forms of notation will be used very regularly in calculus. But now that's out of the way, let's focus on how can we find these functions. So let's say that f prime of x, the slope of the tangent line at any point of x, is equal to the limit as h approaches 0 of f of x plus h minus f of x over h. Now, if you don't really know where we go, I'm sorry, this is the limit as h approaches 0. So if you don't really know where I got this from, see my previous video about what is a derivative, and this kind of explains where we found this. But in that video, I did use f of a plus h because I was focusing at one specific point of x, but this is for just in general the function in terms of x and the derivative of that function. So this is for any value x. Now to find this function, we would first need to know what f of x is. And then we would plug this into this kind of formula, and we would end up working with that. Because if we substitute 0 right away, we would get f of x plus 0 minus f of x over 0. And that ends up being 0 over 0, which is indeterminate form. So just substituting that value of h isn't going to give us any results. But with a function, if we can define the function of f, we will be able to work with this kind of setup and simplify to some things that we can then substitute 0 and find the derivative of. So let's say, for an example, f of x equals x squared. To find f prime of x, that would equal not f of x plus h minus f of x, because now we have a defined function for f. So we'll use this instead of that. So we'll say x plus h squared minus x squared. See, we plugged x plus h into f to find f of x plus h. And that gives us x plus h squared minus x squared. Now, again, if we were to substitute 0 in with that limit, we would get 0 over 0 as indeterminate form. But if we factor this x plus h out and simplify, we might get something that we can work with. So let's do that. So we know that x plus h squared is equal to, here, let me copy this down. So we have this down here. So we simplifying this numerator here. So instead of writing x plus h squared, we know that factoring that out, that ends up being x plus, here I don't need that parenthesis, x plus 2x h plus h squared minus x squared over h. Now again, if we substitute 0, we haven't canceled anything out yet, so the limit would still be indeterminate. But we see in top, x squared and negative x squared here kind of cancel each other out, so they're gone. And what's left with is 2xh plus h squared. And we see we have an h in the bottom and we have h in both terms on top. So these will actually cancel out. And one of those h's will cancel out. So what we're left with is the limit as h approaches 0 of 2x plus h. And then we substitute in that value of 0 to find the limit, and that is 2x. So this function, 2x, is the function of the derivative, f prime of x. And what this function tells us is that for any value of x, 2x will be the slope of that point on f of x. So let's say x equals 4. The slope or instantaneous rate of change in this case, the rate of change of the function at x equals 4. So the slope of f of x at x equals 4 equals 2x. So 2 times 4, or 8. And if we had some form of units, we would apply that here. So like if x was a position graph, So position versus time graph. When you had x equals 4 seconds, the slope would be 8 meters per second. So it would actually be the velocity. But that's more of a physics thing than a calc thing, but it's still helpful to understand that. So that is generally the whole process. There is a second and much more effective trick that I will cover in another video of finding that function f prime of x. But this definition of a derivative is what we call this actually. Here I'm too zoomed out. The limit as f of this is what we call the definition of derivative. And this will be used with many different kinds of functions to give a more generalized set of rules and tricks that we can use to find this new function f prime of x. But that I will save for another video. So thank you for watching, and keep keep getting interested. I hope that calc can be interesting for you, because this is all really such fascinating stuff, and this is just the beginning. This is just the fundamentals of calculus that are going to expand upon each other and develop into this really interesting and really intelligent and clever kind of math. So this is the end of this video. Thank you for watching.